Hello everyone, this is section 5.3, still with normal distributions, but now we're going to look at basically the reverse of finding z-scores, that is finding x values or data values. So the objective is to find a z-score when given the area, so reversing the process. Instead of being given a z-score and finding the area, we're going to be given the area and finding a z-score, and then the goal is to transform that z-score to a data value by using our formula for z-scores, but basically an algebraic manipulation of it. So this summarizes the idea, a little note here as I just explained. And also, when we look up at areas, we'll see through examples, the exact area may not always be found in the entry of the table. Now, when I'm talking about looking up an area, if we look at table 4, I'm talking about looking at what I call the guts of the table. Okay, so for example, if I'm looking for an area of 0.9, 90%, then it's 0.9000, and if I look amongst this list, okay, I've got a choice between these two. See, 0.9 is not exactly a value in the table, so we take the closest one. So in that case, the z-score would be, okay, we've got to read over here to, looks like 1.2, and then 1.2 and then 8, right, for 0.8997. Now, if it falls identically in the middle, like if you were looking for 0.951 here, it falls identically in the middle. So you would split the difference, and you call that, okay, the z-score would be negative, or would be 1.6, and then it's right between 5 and 6, 0.05 and 0.06. So if we cut it down the middle, 0.055. So 1.655 would be the z-score. Okay, so we'll see that for our examples as well, but I thought it might be nice to mention it right away. And you could read through the note, which explains that formally. So here's finding a z-score that has an area of 0.3632 to its left. So what you want to do is you want to draw the distribution. So proceed as normal. And always locate the z-score of 0 down the middle. Now, one thing to know, of course, is that the z-score of 0 splits the data in half, because that's the mean. So there's 50% to the left and 50% to the right. If I'm looking for a situation where there's 0.3632, or around 36% to its left, I know that that data value is somewhere less than the mean, because it's less than 50%. So this is the z-score I'm looking for. And we're told that, remember, the table 4 gives us the left cumulative area. So if I draw my left cumulative arrow, that's basically telling me that I have 0.3632 is the area to the left of that z-score, so in that tail. So we're going to look in, again, what I call the guts of table 4 and try to find 0.3632 or something close. And so when we break out table 4, 3632, well, I know it's going to be in the negative region, right, of the table, because it's less than 50%. So let me go to the negative z-score chart. And perusing this chart, trying to look for 3632, looks like it is actually an exact value. Okay, so then we read the z-score corresponding to that entry. So it was negative 0.3, and then here it is in the column that is, so the row was negative 0.3 and the column 0.05. And so the z-score we're looking for is negative 0.35. Okay, so now it says find the z-score for this part. 10.75% of the distribution is to its right. So first we've got to convert the 10.5% to a decimal. So 2 places to the left, 0.1075. Alright, so that means in our distribution, we have, okay, you have to think about first off, you have to think about what side of the mean we're on. Well, if 10% is, around 10% is to the right of this z-score, then that means around 90% is to the left. So we're on the right-hand side, and that's the z-score we're looking for. And we have to calculate this left cumulative area, because that's the area we're looking up in the table. We're given that this area in here, our little right tail, that's the 0.1075. So therefore, the area to the left of that is the complement, 1 minus 0.1075, or 0.8925. So now we want to look up 0.8925 in the guts of table 4. So now I know I'm dealing with a positive z-score. So I use the positive end of the table, and looking for 8925, and it's an exact value again. So this corresponds to 1.2 is the row, and the column looks like 0.04, so 1.24. Okay, and then this one asks, find the z-scores for which 80% of the distribution lies between negative z and z. So make a sketch of the situation. Got our normal distribution. And get the z equaling 0 down the middle again is always something we want to label. And we're told that between negative z and z, there's 80%. So let me do it this way. Let me say that this is, going to change 80% to a decimal, of course, get 0.8. I'm going to say 000 because we have to know we're looking up the area, so 4 decimal places. Z-scores are 2 decimal places, but area we go to 4. So we're basically told that 80% or 0.8000 is in these regions. So that means the easiest, let me mention this, when you're working with a situation like this, where you have symmetrical z-scores, it's easiest to work off of the left z-score. So, because the table gives us left cumulative areas. So I'm going to work off of that one. And the way we could determine the area, because we're told this is the area, right, of 80%, the way that we could determine the area to the left of that is to realize that symmetrically, between the mean and either one of the z-scores would be half of the 80%. Or in other words, between negative z and the z-score of 0 is 40%, or 0.4000. So therefore, since 50% lies to the left of the mean, the area in our left tail here is going to be 0.5000 minus 0.4000, which gives us 0.1000. So that's the area that we're going to look up in the guts of table 4. So again, alright, so now we're on the negative portion, and we're looking up 0.1000, and it looks like it's between these two values, 0.0985 and 0.1003. But it's closer to 0.1003 because it's only 3 10,000ths, or 10,000ths, hundred thousandths, 10,000ths, yes, 3 10,000ths away, and this one is 15 10,000ths away, so it's closer to the 0.1003, so negative 1.2, and then it's in the column of 0.08, so negative 1.28. So that's the left one, and the right one is just going to be the positive. So what we'll say is plus or minus 1.28. Okay, continuing. First off, recall the concept of percentiles. First off, percentage means 100%, or per 100. So percentiles divide the data into 100 equal pieces. And the key to percentiles, whenever you think of percentiles, think of below. Okay? You want to be in a high percentile. Because if you're at the 90th percentile, if it's a good thing you're talking about, if you're at the 90th percentile, let's say in the class, with your class average, then there's 90% of the people below you. Okay? You might not want to be in the 90th percentile weight, right? Or something like that, but you'd rather be in the 90th percentile of in your class. But always think of below. And we give it a little example. 20th percentile would mean there's 20% of the data below that value. And we have this little notation, P with a subscript of whatever the percentile is. So also recall, first quartile is the 25th percentile, second quartiles the 50th percentile. Actually, this is also the median. And the third quartile is the 75th percentile. So now it asks us to find the z-score that corresponds to P sub 5, 5% of the data below. So that's what P sub 5 means. P sub 5 means there's 5% below this data value, or this z-score. So you always want to make a sketch. The sketches are very helpful. So if I make a sketch, basically it's just telling me in this case, this is z equaling 0. There's 5% below, so we'd be on the left, because this area is 5%. Now 5% is 0.05, but we'll add a couple zeros again, 4 decimal places. So 0.0500. And so that's the area in that tail. And so that corresponds to a z-score of, again, go to the guts of table 4, 0.05. Looks like it's smack dab in the middle, right? Between 0.049 and 0.05, not 005. So 0.05. Let's see where we're at. Oh, looks like we're smack dab in the middle there as well, between 0.495 and 0.505. We're both 5 10,000ths away. So what we'll do is we'll cut the z-score We'll cut it in half there. First off, the leading digits are negative 1.6, and then we're in between the 0.04 and the 0.05 columns. So therefore, we'll say negative 1.645 would be right in between those two. So negative 1.645. Okay, so moving on. Now we're going to consider transforming a z-score to a data value. This formula is basically just an algebraic manipulation of the z-score. Here, I'll show it real quick for you algebra fans. If you take x minus mu over sigma, and you want to solve for x, you don't have to worry about this, but this is just for the fans of algebra. We'll multiply both sides by sigma, and let me say this is z sigma equaling x minus mu, because the sigmas over here cancel. And then if we add mu to both sides, we have mu plus z sigma is equal to x. So that's actually the algebraic manipulation that gives us this formula. You don't have to worry about the algebra there. You just have to know to use that formula. And it is on our table, or on our formula sheet, that is. So if you look under key formulas, right under our z-score, they even tell us transforming a z-score to an x value. So you have to know whenever you have to change from a z-score to an x value, use that formula. So here's just practice on plugging in the numbers, because everything's a given. That is, the formula once again is x is mu plus z times sigma. So we have mu is given to be 70.2 plus z. Okay, we got to be careful here. That's a negative 1.75 times sigma of 4.5. So just be careful with the computation, because that negative. So it's 70.2 minus the product of 1.75 and 4.5 is 7.825. And that gives us 62.325. Okay, so if we want to find the x value when given a z-score, or actually when we're given an area, okay, on the distribution, because then we basically go from, as this little procedure outlines here, okay, you're going to identify the givens, right? Sketch the distribution and shade in the given percents, and you're going to find the z-score associated with that given percent. That given percentage is basically an area, right? So we go from area to z-score, and then from z-score to the x value. It's the reverse. Instead of giving an x, calculating z, and finding the area, we're given the area, find the z, and get the x value. Alright, so let's lay out this problem. Off to the side, I'll rate the givens. So test scores for an exam, normally distributed, pretty much always mentioned, right? Mean, 75, so mu is 75. Standard deviation of 6.5, so sigma is 6.5. We want the top 5%. Okay, so if you're in the top 5%, then there's 95% below. And remember, that's our left cumulative area, is below to the left. So the 95% corresponds to 0.9500. So when we draw our distribution, we're talking about, again, always label z equaling 0 down the middle. We're talking about a situation where in this tail, there's 5%. 5%, let me change that, 0.05, right? So in that tail, there's 0.05. And that's the z-score we're looking for. But we want the left cumulative area to find that z-score. So that's going to be 1 minus the 0.05, or 0.95. And at that point, I'll add a couple zeros to reinforce the fact that I have to go to the guts of the table. So now we go to table 4. Let's say the guts of table 4, and we find the corresponding z-score. And I think that was the one we just did moments ago, right? Or actually the opposite. But let's do it again, 0.95. So look for 0.95, and looks like it's right here, between 0.9495 and 9505, and it's smack dab in the middle. So 1.6, and we're splitting the 4 and the 5 again. So positive 1.645. Okay, so now we go to our formula for the data value. X is mu plus z times sigma, and just plug in. So mu is 75, so x is 75, plus z are 1.645, and then times sigma was given to be 6.5. And so if you crunch all that down, just double check my work here. You get 85.6925, and then just pay attention to where they want you to round. Okay, so then a final example for this section. Person spends an average of $50 a week on groceries. Okay, so it's good practice to just do these givens off to the side. Average mu 50. Standard deviation sigma is 8. Find the minimum and maximum dollar amount spent for the middle 60% of one-person households, and assume it's normally distributed. Okay, so the middle 60% is what we're looking for. Alright, so let's make a sketch of that. And we have z equaling 0 down the middle. Okay, so we're middle 60% means that we're on either side of the mean. Got a negative z-score to the left and a positive z-score to the right. And in this shaded region, or between those two values, is 60%, or 0.6, and say 0, 0, 0. So we did this earlier, remember, with when you're working with positive and negatives z-scores. You can call this negative z if you want. It's easiest to work with the one with the negative z-score, so we'll look for that left cumulative area. And if 60% is between negative z and z, between negative z and the mean, is half of that, or 30%, so 0.3000. And since there's 50% less than the mean, then the area to the left of our negative z-score, okay, for sake of room, I'm just going to say 0.5 minus 0.3. That's the 50% minus the 30%, and that gives us 0.2, and we'll add 3 zeros to that, because that's the z-score that we're going to look up in the guts of table 4. Alright, so one final visit to table 4, and for this section, looking for 0.2. We know it's a negative z-score because it's less than 50%, and 0.2 looks like it's closer to the 0.2005, and so that's a negative 0.8, and then the column looks like 0.04, so negative 0.84. Alright, so that's our z-score, and now for the x value, well, there's actually 2 of them. Let's do it this way. Because we've got 2 z-scores, the negative 1 and the positive 1. So the negative z is negative, and the positive z is positive. Alright, so the minimum is going to be when z is the negative 0.84. So then into our formula, I won't write it again, but it's right here if you need to see it again. X is mu plus c sigma. So x's mu was given to be 50, that's right here, plus z, negative 0.84, times sigma, which is 8. And just be careful of the negative on your computations, and we get 43.28. And then for the maximum, that's when z is positive, 0.84. So then we get that x equals 50 plus a positive 0.84 times 8. And we get 56.72. Okay, so that's the end of section 5.3. And we'll see you when you are ready for section 5.4.